Okay, today we're having a look at roof frames. So here's an example of a roof frame. So let's start here by having a look at the rafters. So the rafters are two pieces that comes together like this. You can see here it makes almost a V shape. So that's the rafters, which is the frame of the roof. All right. Then we've got a tie beam. So the tie beam is the beam that joins the rafters together like this. Come on, there we go. No, wrong button. There we go. It joins the rafters together like that. That is the tie beam. So what it does is it joins the rafters, and by joining the rafters, what it does is it takes the load, the force, the load from these rafters, and it spreads it to the walls, because the wall is underneath here and the wall is underneath here. Let's insert a thing like this to show you where the wall is. There's the one wall, and then the other wall is over here. Okay, so the tie beam spreads the load to the walls. Then we've got something called the king post. So think about it, it's the king post, it's the highest post. So the king post starts in the middle of the between the rafters and goes to the middle of the tie beam. So it's upright and it connects the rafters and the tie beam, and it strengthens the frame. Right, now we've got a queen post. So let me first insert a truss here. Yeah, let's talk about struts first. So struts goes from the king post to the rafter, and the purpose of that is to strengthen the structure. Okay, so here we've got struts, and it strengthens the frame by binding the structure together. Okay, I just want to quickly mention triangulation. I'm sure you remember what that is. Triangulation is using triangles in building and in frames to strengthen things. So you can see this king post makes a triangle, and these trusses make further triangles. So the more triangles we've got, the stronger our structure is. Right, then we get a different type of roof where we have a truss. So those small ones were struts, and now this one is called a truss. A truss goes over the length like this, and then we've got a queen post that supports the truss. So it supports the truss and therefore makes the truss able to go over bigger distances. So the queen post goes here between the tie beam and the truss, and if you've got a queen post, this truss go over a long area, and the queen posts keep it upright. So it allows the roof truss to span over a larger distance. That's what the queen post does. So let's look at this picture here. We've got the rafters. Here we've got the tie beam at the bottom. The king post is standing upright, and the struts bind these together. In this structure of a roof, we've got a truss and a queen post, 2 queen posts. Right, then we can get different types of beams. So here we've got other beams. So the other type of beams we've got, the first one is a cantilever beam. The cantilever beam basically sticks out. So it is only supported on one side. So it only carries a load on one side. So you can have a look at this picture here. We've got a column here, and this is the cantilever because it sticks out. It's only attached to one side. Here we've got another one. So we've got the post here, and then the cantilever beam going this way, and it's hanging loose on this side and only supported on one side. Okay, here we've got some balconies. So it's attached to the wall here, so it carries the load on the wall side, and on the other side it hangs free. Then we also get lintels. A lintel is a beam that supports the wall above the windows and the doors. So here we've got a window or a door and the lintel, you can see, is a solid concrete thing that goes on top of it, and basically what that does is it supports the window frame so that the load here from the bricks at the top doesn't crush that. So it supports the wall above windows and doors. Let's have a look at arches as well. So what's the purpose of arches? I'm sure you've seen before, especially Roman architecture, Greek architecture, cathedrals, churches, that type of thing has arches. So on the left side here we've got an example of an arch. This one here in the middle, the stone in the middle, is called the keystone, and it keeps the arch from falling apart. But basically, let's have a look at why do we use arches. So the first thing is just because it looks pretty. It's decoration. It looks nice. So many churches have arches because it looks nice. So it's decoration. We also have, in the Roman times, they built a lot of things with arches, and here is an example of an aqueduct. Now aqua means water, and duct is like a transport thing, usually a pipe or something like that. So an aqueduct basically carried water. Remember, they didn't have underwater pipes yet, so they used aqueducts on top of the land to carry water pipes. And the aqueducts were mostly used in arches. Okay, then arches can also be used to support things. So here we've got an arch bridge. So the arch here helps supporting the load of the bridge. So in an arch bridge like this, the columns over here carries the load. Let's put in an arrow there, then you can see what I mean. So the load comes down like this, and the arch carries the load here on this side, or the arch, sorry, let's restate that. The arch supports these beams. So the beams here on this side, these columns, carries the load, and the arch supports those. Alright, so arches for support. We have arches for decoration, arches for aqueducts, and arches for support. And while we're busy looking at bridges, let's have a look at these two bridges as well. So this was an arch bridge. This one we've got here is a suspension bridge. So the suspension bridge, we have these towers here. We have these towers here. Those two towers and these two towers on this side. And those towers carries the load. Okay, let's point it at the tower. So what we've got is in a suspension bridge, there is a cable running between the two towers and cables hanging down that supports the bridge. And in a cable stay bridge, we've got a very similar thing. We've got the two towers and the cables going straight from the towers onto the bridge. Okay, so that's a suspension bridge and a cable stay bridge. And if you have a look over here, the load is carried by the towers, where on an arch bridge the load is carried by the columns. So what can cause structural failure? So what would cause this bridge to collapse? First of all, if the beams break, then that can cause the bridge to collapse. If the load is uneven, like let's say for example, this piece here on this side where I've got this arrow is carrying more weight than this one on the other side, on the left side, then the load is uneven, and because this side carries more weight, it's going to break more easily. Okay, then we've also got if a beam is not strong enough to carry the load. For example, this tower here isn't strong enough and it can't carry the load of the bridge. Then we can also have structural failure. Let's go back to the roof. Here we had the roof frames. So let's say for example this strut over here is not strong enough, or the load is uneven, that any of these beams basically. Let's have a look at this truss here. So if that truss, let's say this truss and this truss is not equal, then the one carries more weight than the other one, and then the one carrying the bigger load will break. We can also have a reason for structural failure. Let's say this beam is very weak. This rafter has been eaten by termites, and therefore it's weak and it breaks. So you can see there are many different reasons for structural failure. It can be anything from the beams not being able to carry a load, and there are tons of reasons why this could be. There are beams breaking. We've got uneven loads, and we can have weak beams if the beams simply aren't strong enough. So there are tons of different examples of structural failure and why they happen. These are just a couple that you can have a look at. And then in the next video, we'll do machines.